All right, I had a question today about Module 6, Week 12, Day 2. So I decided maybe I was going to go over the notebook journal with you guys. All right, so let's talk about this. What is motion? All right, so motion is defined as a change in position. The world around us is alive with motion. Every single thing is moving. So then what is the science of mechanics? Mechanics is the branch of physics that deals with analyzing and understanding objects in motion, the forces applied to those objects, and the energy that exists in them. So why do we have frames of reference? What does all motion is relative mean? There are no perfectly stationary objects, as I just mentioned. Every single thing is moving all around us. So there are no perfectly stationary objects to use to judge motion. All motion is relative. And in physics, motion is always measured relative to something else. And that something else is usually called the reference point. So then the particular definition for a reference point is a point against which direction is measured. All right, so here we go with this picture, and this is all in the book too. Describe at least 2 frames of reference for the photo. So a frame of reference refers to using a reference point to detect motion. So here we have the picture, some people enjoying a roller coaster. All right, so for the first point of reference, if you are the observer standing on the ground, so if I'm the reference point standing on the ground, the people in the figure are definitely moving relative to me because I am the reference point standing, just looking at the roller coaster flying by. So they are the ones that are definitely moving relative to me. Now, if I am the person sitting in the seat, so if I'm the reference point, then the person sitting next to me is not moving relative to me. So again, if I'm on the ground and I'm watching the people in the roller coaster fly by, they look like they are moving relative to me. If I'm sitting next to someone, we're both moving together at the same speed, at the same direction. It seems as though none of us are moving relative to me. All right, so what is distance? Distance is the length of a path between 2 points. Distance does not need a reference point and does not need direction. And again, I think either the first or second module, we talked about the SI unit for distance, which is length, which is the meter. For very small distances, we would use centimeters, and for very large distances, we would use kilometers. So then how is distance different than displacement? All right, so like I said, distance does not need a reference point and does not need direction. Displacement needs distance traveled as well as the direction of motion from the starting point. All right, so here are just some simple vocabulary words that are defined in the book. Displacement is the distance an object travels plus the distance from the starting point, the change in position of an object. And really, you use displacement, it's best used for giving directions somewhere. Vector quantity, a physical measurement that contains both magnitude, which is a number, and directional information, like east or north or west or to the right or to the left, up, down. Scalar quantity is a physical measurement that contains only a number and does not contain any directional information. All right, so if I wanted to add vectors, you can add vectors by combining the vector magnitudes and directions. To add vectors, you must account for direction, which then leads me to this page. We have some people walking. All right, so let's talk about A, which is displacement in a straight line. All right, so this guy was walking. He walked 4 kilometers, needed to stop, take a break. Then he walked 2 kilometers more. Both times he was walking in the same direction. We can call it east. Based on the compass rose up there, we can call it east. So for the distance, we say 4 kilometers. So 4 kilometers from here to here, plus 2 kilometers from here to here, gives a distance of 6 kilometers. Now, displacement, we need some kind of direction with that. So again, he started here and he ended up 6 kilometers east. So displacement is 6 kilometers east because he ended up being 6 kilometers east of where he started. All right, now let's move on to B. It's still displacement in a straight line. So here, same guy, he walked 4 kilometers east. Then he realized, oh no, he dropped something back here. So then he decided to walk 2 kilometers, and again, we'll call that the opposite direction, or west. So he walked 4 kilometers east, and then he walked back 2 kilometers west. So now the distance he still walked 4 kilometers and 2 kilometers. So he still walked 6 kilometers. That didn't change. However, his displacement did. From where he started to where he ended, he was only 2 kilometers east. That's a negative number there. So we're saying he walked 4 kilometers. And if I added the negative direction in there, so minus 2, I get 2 kilometers east. So once again, he ended up being 2 kilometers east of where he started. Okay. Now, displacement not along a straight line. So again, we are talking about this right here. All right, the distance. He walked 1, 2, 3, 4, 5, 6, 7 kilometers, or 7 blocks. So he walked, his distance was 7 blocks. Now his displacement, this is the tricky part. You need to get a ruler and you need to measure the distance. Okay, so let me try to do this with you guys so I can show you. So it looks as though my reference point is about 11¼ millimeters. So now I have to figure out each block is about maybe 2¼ millimeters. So 11¼ divided by 2¼ is 5. So once again, my displacement is 5 blocks northeast. So again, it's my starting point to my ending point is 5 blocks northeast. To find the displacement of the person walking to the restroom, you need to find the distance and the direction from the starting point to the ending point. All right. Lastly, the on your own. The answers are pretty well written out in your textbook, so you can go ahead and turn to the back of Module 6 to get those answers. I kind of hope this helped. We'll go over this in class on Monday.